Hi there. It's a great honor to share at the Next.js conference. Today's topic is about how Tencent scales to millions with serverless Next.js and achieve 100% performance improving, also 90% cost saving. First, let me introduce myself. I'm Tina Fang. I'm currently based in Shenzhen, China. I'm a service advocate and also work as a product manager at Tencent Cloud. Here's my Twitter and GitHub account. Well, my topic will contain the following parts. First, I will introduce the background and why Tencent chose Next.js to do the SSR. Then I will introduce the architecture of Tencent Next.js. After that, I will show how we combine serverless with Next.js to improve the performance and also save the cost. At last, I will demo a volume made by the serverless Next.js. Okay, before that, let me introduce Tencent in a few seconds. Tencent is one of the world's top technology companies and provide various services include the social network, the music, e-commerce, and mobile games, etc., etc. The most famous applications in Tencent are the instance masters named QQ and WeChat. And why we are using SSR? The story begins from the end of the 2019, as we know that the coronavirus makes the online education requirements rise rapidly, and all the Chinese students they have to study at home. The online student raised from like 40,000 to 300,000. So we have about 10 times increase during the first half year of the 2020. And the students use Tencent softwares like the ABC Mouse, the Penguin Education, and also the Tencent course to do the e-learning. In order to get more market share and make better user experience, we would like to use SSR in all Tencent online education applications. Well, why SSR is so important for our PC and also the H5 users. Compared with the CSR, the client-side rendering, basically I think it have two advantages. The first one is performance. Usually we use the first contentful paint and the first meaningful paint, the FCP and FMP to verify the performance of the application. And the SSR can make great FCP. Thus, users can have a streamlined experience when they open the page at the first time. And the second one is related to the SEO. Compared with the CSR, in the server-side rendering, all the HTML content is present in the source code, which means the search engine they can request and index it immediately, resulting in a faster time to actually appearing and ranking in the search results. Well, the SSR is fantastic in the SEO and performance scenarios, but why are we not using it until 2020? Because the SSR has a lot of challenges especially for the front-end engineers, especially in a large company. Well, in Tencent, every position is responsible for specific duties, and the communications across team become even harder. We know that the front-end engineers, they are really good at making UI and making web pages. Well, if they want to create a SSR application, a front-end engineer needs to maintain the node server by themselves and also responsible for scaling up servers when needed. Besides, they have to learn how to make some maybe Nginx configurations from the access layer to servers, as the servers and the configurations are usually maintained by the operation engineers in Tencent. So it's really hard to make a SSR application in the product environment all by the front-end teams. Well, it turns out that using serverless to replace the SSR node server can solve the problem perfectly. Well, for the front-end engineers, they don't need to maintain the node servers and the complex configurations, and also the serverless functions can auto-scaling according to the traffic. And also from the cost-saving perspective, the serverless functions can pay as you go, thus they can reduce the server cost. For the above reason, the Tencent Education team is trying to combine serverless and also the SSR together to improve their softwares. Next, I would like to talk about why we choose Next.js as the SSR framework. As we know, the Next.js is a lightweight React-based framework that can support SSR use case perfectly. It has the SSG, the static site generation, and also SSR support, also flexible dev tools. It's also one of the most popular open source projects with more than 50,000 stars. Besides, in our use case, it is perfectly matched to use SSR with hydration. Firstly, all the online courses, these pages have public access for the users. Thus, the SEO is very important for the website. And also, we want to retain users by the streamlined experience because we will lose them if the page content loading for a very long time. And secondly, we would like to use the dynamic HTML rendering per request because each client may see the different recommended content. For example, the children under 12, they need to see their customized pages, and the adults, maybe they have more interest in other courses. Well, next I would like to introduce the architecture of Tencent Next.js application. Well, as the diagram shows, at the top level, we have ABC Mouse and also Penguin Education and so on. And the users can get access to them by visiting the H5 and the PC pages. After that, we got a DNS for domain mapping and an API gateway to do the proxy. The proxy will dynamically route the request to the cloud functions, which are used to do the server-side render. And these functions have some utils components for maybe for the code reuse and also for the logs for monitoring SDK. And in the official websites, all the course page and the search discover pages, they are building in these cloud functions. Besides, there are some modules to do the log tracing and also the data searching, data analyzing by the Elasticsearch and Grafana. We also monitoring the failure rate and the latency of the page, and then configure the real-time alerting for them. And for the workflow part, we use the CLI to auto deployment and integrate with the CI/CD pipeline. Then let's see how we improve the performance of the Next.js application. In order to make the performance better, firstly, we are trying to use the LRUCache to accelerate this application. Like the code shows, we use the render to HTML to get the string and put them in the caching. Then we found that this API seems to be a private API and being removed by the Next.js community in the latest version. So we can find the discussions in the link below. Well, in our use case, it will be very helpful to use caching in the whole project. So we hope the community can add a lower API for rendering manually. Maybe the render to HTML can be used for caching and more flexible and allow users to customize according to their needs. After that, we analyze the data we need to render from the database. And we found that some of the data is not changed frequently, while the others are always changing. So we call them the static data and the dynamic data. For example, in the web page, the course the course name and also the descriptions, they are not often changed. Well, some login related data like the discount of the courses and also the payment status is always changing. So we separate them and put static data in Redis for caching. Like the diagram shows, when a user visits the website, it will first find if the data is in Redis. If not, we will get from the static CGI and use render to string to do the SSR, and also write the result to Redis. And don't forget to set an expire time for this data. And for the further step, we are using the PWA, the Progressive Web App, in the client side to store the HTML page. The onboarding flow is also like the diagram shows. First, the users visiting the website, they will first using the PWA to get the offline data, and then to get the dynamic data to finish the render. If the data is not in the PWA, it will read Redis or the other API to get the static data again. Then it will update the PWA. After that, the users will get more smooth experience by using the data caching. And another functionalities we use in the Next.js framework is the custom server. Because our original server is developed by Koa and Express.js, we use them as the custom server for the dynamic API routing. Thus, we have to use the module export to create servers instead of listening to a specific port like 3000. It will be more flexible and customizable for our API routing. Here is a demo for the custom API routes we used in the project. We are using the Express.js and to make the get and the about and topic APIs. As I mentioned before, our architecture is all made by the serverless services. So let's see what we have in a basic Next.js application and how we use serverless service to improve the performance and also save the cost. For the access layer, we got DNS, and then we using the API gateway to handle and route the request. In order to accelerate pages, we got the CDN, the delivery network, content delivery network, and also the object storage to host the static assets. And for the computing part, we use functions as a service to do the rendering work, and they will get essential data from the serverless DB. And using this service, we achieve 100% performance improving and also 90% cost saving. Let's see in details. Well, the Euro Next.js network is about like 200 megabits, and the static assets are huge. So deploying them in functions will make it slow and even make the code start. So we are trying to separate them with dynamic assets. In our Next.js applications, we usually put the static resources like pictures and videos in the .nextjs/static folder. And also, there may be some files in the public folders. For the first ones, we have to update the nextjs.config.js after creating an object storage bucket, and then replace the static URL by the cause URL. And for the second ones, we have to change the file reference in the code, like it shows in the slide, using the parameter process env static URL to ref the assets in the public folders. Besides, because the users are all in all the country and even in different countries, so it's necessary to keep them get streamlined access for the sites. So we config a custom CDN domain to do the acceleration. Well, the CDN we use have more than 1,000 nodes and distributed in more than 50 countries and regions. After the improvements, we can see the access experience for the Penguin course page is pretty good in the mainland China. As the test result shows, for 93 access nodes in the different provinces in China, the average latency is about 600 milliseconds. And another things I would like to mention is that we are also using the layer in service function as a service to store the node modules. In order to accelerate the deployment process, all the dependencies will not be changed frequently, so we separate them, and the functions will also be loaded faster if they are using the layer functionalities. After using the serverless architecture, we find that the cost saving happens in three parts. It's the labor cost, the resource cost, and also the efficiency improvement. The serverless Next.js architecture don't need operation engineers to do the extra maintain job, and it also makes great resource saving because the online cost has peaks and valleys like the following picture shows. From the September 12th to October 12th, the peak of the page visiting is 260,000 per day, and while the visiting is only about 50,000 in the spare time. And it's related to the go-to-school time for students and also some marketing events. So in this pattern, the serverless services can reduce 80% of the server cost. Time to market is important for all the enterprises. Serverless makes it faster to make an idea to the product. For example, by using serverless, a new functionality can be developed in 2 days with one full-time employee. Well, it used to be 7 days with three full-time employees. And at last, I would like to introduce that what we do for CI/CD and monitoring. It's important to integrate with the CI pipeline to prevent manual mistakes. Currently, we integrate the CI/CD with Tencent internal CI platform named LRUCache, and it's also pretty easy to integrate with the GitHub Action and coding CI like the slides show, which is also very popular in China. And in the LRUCache, the front-end engineers can ship a new version by easily submit a release ticket. It will be automatically built, tested, and then deployed to the pre-release environment. After verifying, it can be manually approved and shipped to the product environment. Besides, we really need a comprehensive dashboard to see the whole application status. By using an agent named the Serverless SDK, the metrics of the service and also the application itself can be reported to ES and showing in the Grafana. And usually we will check in the metrics below. Well, the API latency, the 400 and 500 status code, and also the API request, API errors, API pass errors, pass request. And it makes it easier to find issues in advance. We also configure the alerting, and it will send the SMS and WeChat notification when any of the policies is triggered. Here is also the Grafana dashboard and also the real-time alerting notification we received by the WeChat mini program. Okay. At last, I would like to make a quick recap for what we do in Tencent Serverless Next.js. By analyzing our use case, we use data caching like Redis and PWA to accelerate our web page. And we also use custom server like Express.js to routing APIs dynamically. Besides, we found that serverless is perfectly matched for the SSR use case because it can auto-scaling and also pay as you go. And combined with the serverless service, we can deploy a Next.js application faster and easier than ever. We made the following improvements to create a serverless Next.js application. We use the fast and API gateway to deploy Next.js framework, and also using layer to store the dependencies. We also use cost to separate dynamic and static assets, and use the custom CDN domain to do the acceleration. And for the monitoring and alerting, we report the application level metrics and show them in the dashboard. After reporting the logs to ES, we can also see the real-time status in Grafana and get the WeChat notification immediately when there is an issue. So we will continue to we also combine the internal CI to deploy and test new features automatically. Well, the current architecture still has things to do, such as the troubleshooting and a complete end-to-end log tracing system. It's currently it's hard to find the performance issue now. And besides, we have plans to open source the project and make it vendor agnostic to support like different cloud providers like AWS, Azure, and also the Tencent Cloud. Then the other companies who need it can reuse the architecture. Currently, we have to change the Next.js config.js manually. So the next step, we also have plans to automatically config the Next.js project and make better combination with the cloud infrastructures. Well, at last, I will make a real-world serverless Next.js demo based on the Tencent Online course use case. It's a very popular Chinese dynamic volume named V2EX. We can deploy the demo on the serverless architecture in one command. Well, as the lighthouse shows, the performance is much better after using the serverless Next.js. Well, we can using one command the serverless deploy to deploy the whole project. As the deploying goes, we can see in the serverless YAML, we have all the configuration of the cloud services, like the functions, the API gateway, and also the CDN domains. Well, in the next config.js, we can see the CDN domain to do the acceleration to host the static assets. And also in the servers, we are using the Express to do the custom server for the Next.js framework. Well, as we can see, using like 20 seconds, we already deploy all the project. Let's see the performance of V2EX sites. Well, it can be load pretty fast. And here in the slides, there is an open source link for this volume. So feel free to deploy it by yourself. Well, that's pretty much what I would like to show today. And thanks for your listening. Please feel free to ask me any questions. Thanks again.